Now, before starting the problems, the three things which we have proved, just we have to remember these things very well. This is 1. Sin square theta plus cos square theta is 1. The second result is 1 plus tan square theta is secant square theta. And the third result which we have proved is 1 plus cot square theta is equal to cosecant square theta. Okay. Now, sine. Here this is cos and sine. To express this completely in terms of sine square, we have to change this cos square alpha. And we are familiar with the formula cos square alpha plus sine square alpha is 1. Therefore, cos square alpha can be written as 1 minus sine square alpha minus sine square alpha. Therefore, this is 1 minus 2 sine square alpha. This is the result which we have proved. To prove the third result, cos power 4 alpha minus sin power 4 alpha is first we have proved that it is cos square alpha minus sin square alpha. Now here we are asked to prove that it is equal to 2 cos square alpha minus 1. That means it is complete in terms of cos. Therefore, this is cos and this is sine. The sine square alpha, we have to convert it into cos. Now, cos square alpha plus sine square alpha is equal to 1. Therefore, this is sine square alpha can be written as 1 minus cos square alpha. Therefore, this is cos square alpha minus of 1 minus cos square alpha. Therefore, this is cos square alpha minus 1 plus cos square alpha. These two becomes 2 cos square alpha minus 1. So, cos power 4 alpha minus sin power 4 alpha is equal to cos square alpha minus sin square alpha. This we have proved it in the beginning. Now we have to express this completely in terms of cos square. Cos square plus sin square alpha is 1. Therefore, the sin square alpha can be written as 1 minus cos square alpha. Now this is cos square alpha minus 1 minus of minus plus cos square alpha. So this plus this is 2 cos square alpha minus 1. Now cos alpha by 1 plus sin alpha plus 1 plus sin alpha by cos alpha is equal to 2 secant. Up to the previous problem, we have got all the problems which are in some algebraic formula. Some of them are in a plus b whole square, a plus b whole cube, and then afterwards a cube plus b cube factors, a cube minus b cube factors, a power 4 minus b power 4. Now this problem is not related to any algebraic formula, and this is something to be simplified. Now cos alpha by 1 plus sin alpha plus 1 plus sin alpha by cos alpha. We have to take the LCM. The LCM is 1 plus sin alpha into cos alpha. This multiplies this and becomes cos square alpha. 1 plus sin alpha and the 1 plus sin alpha becomes 1 plus sin alpha whole square. So This into this is 1 plus sin alpha whole square. Now, this is cos square alpha. This is a plus b whole square. A square means 1. B square means sin square alpha. Plus 2ab means 2 sin alpha. And this is 1 plus sin alpha into cos alpha. Now we have taken the LCM, 1 plus sin alpha into cos alpha. So this is multiplied by cos alpha. It became cos square alpha. Now this is 1 plus sin alpha whole square. So cos square alpha plus a square means 1, b square plus 2ab by this one. After taking the LCM, we will get some standard results in the numerator that we have to make use of it. Now here cos square alpha plus sin square alpha is 1. And 1 plus 1 is 2. Therefore, so cos square alpha plus sin square alpha 1 plus 1 2 plus this is 2 sin alpha, and the denominator is 1 plus sin alpha into cos alpha. Now 2 can be taken as common factor. This is 2 into 1 plus sin alpha by 1 plus sin alpha into cos alpha. These two gets cancelled. This is 1 by cos is secant, therefore 2 into secant alpha. Therefore, after taking LCM, this is cos square alpha plus 1 plus sin alpha whole square. On expansion, this is 1 plus sin square alpha plus 2 sin alpha. Cos square plus sin square 1, 1 plus 1 is 2 plus 2 sin alpha. 2 is taken as common factor. 2 into 1 plus sin alpha by 1 plus sin alpha into cos alpha. These two things gets cancelled. So 1 by cos is secant. Therefore the answer is 2 into secant alpha. Sin alpha by 1 plus cos alpha plus 1 plus cos alpha by sin alpha is equal to 2 cosecant alpha. So once again, this is also the same type, not relating to any algebraic formula, but LCM model. Therefore, sin alpha by 1 plus cos alpha plus 1 plus cos alpha by sin alpha, the LCM is 1 plus cos alpha into sin alpha. This gets multiplied with this and becomes sin square alpha plus this into this is 1 plus cos alpha whole square. So 1 plus cos alpha sin alpha LCM, this is sin square alpha into 1 plus cos alpha whole square. Now this is equal to, this is sin square alpha. On expansion, this is 1 plus cos square alpha plus 2 cos alpha, and this is 1 plus cos alpha into sin alpha. Sin square alpha plus cos square alpha is 1. 1 plus 1 is 2. Therefore, this is 2 plus 2 cos alpha whole by 1 plus cos alpha into sin alpha. Take 2 as common factor in the numerator. This is 2 into 1 plus cos alpha by 1 plus cos alpha into sin alpha. These two things gets cancelled. 1 by sin is cosecant. Therefore, this is 2 cosecant alpha. So sin alpha by 1 plus cos alpha plus 1 plus cos alpha by sin alpha. 1 plus cos alpha into sin alpha is LCM. So this is sin square alpha, 1 plus cos alpha whole square. Sin square alpha, on expansion, this is 1 plus cos square alpha plus 2 cos alpha by 1 plus cos alpha into sin alpha. Sin square plus cos square is 1. 1 plus 1 is 2. Therefore, this is 2 plus 2 cos alpha. And 2 is taken as common factor, 1 plus cos alpha. By 1 plus cos alpha into sin alpha, these two things gets cancelled. 1 by sin is cosecant, therefore this is 2 cosecant alpha. Cos A by 1 plus sin A minus 2 secant A plus cos A by 1 minus sin A is equal to 0. Now, before taking the LCM, here we can take cos A as common factor. So, therefore, cos LHS equal to cos A is common. This is 1 by 1 plus sin A plus 1 by 1 minus sin A minus 2 secant A. And this is cos A. The LCM is 1 plus sin A into 1 minus sin A. Here we will get 1 minus sin A plus 1 plus sin A minus 2 secant A. Now here sin A and sin A gets cancelled, and this is cos A into 1 plus 1 is 2. By 1 plus sin A into 1 minus sin A becomes 1 minus sin square A minus 2 secant A. But this is cos A into 2 by, this becomes cos square A, since sin square A plus cos square A is 1, sin square A plus cos square A equal to 1. 1 minus sin square A is cos square A minus secant A. Cos and square gets cancelled. Therefore, 2 into 1 by cos is secant A minus 2 secant A. This is 0. So, cos A is taken as common factor in these two. LCM is 1 plus sin A into 1 minus sin A. Here we will get 1 minus sin A. Here is 1 plus sin A. 1 plus sin A into 1 minus sin A becomes 1 minus sin square. After cancelling sin A, 1 plus 1, 2. And 1 minus sin square A is cos square A. Therefore, this is cos A into 2 by cos square A minus 2 secant A. Cos A and square gets cancelled. So, this is 1 secant, therefore 2 secant A minus 2 secant A equal to 0. Sin A by 1 plus cos A minus 2 cosecant A plus sin A by 1 minus cos A equal to 0. So here sin A by 1 plus cos A minus 2 cosecant A plus sin A by 1 minus cos A. We can take sin A common in these two. Therefore, after taking sin A as common, we are left with 1 by 1 plus cos A here plus 1 by 1 minus cos A here, and this is minus 2 cosecant A. And this is sin A. LCM is 1 plus cos A into 1 minus cos A Here it is 1 minus cos A plus 1 plus cos A minus 2 cosecant A. Cos and cos gets cancelled. This is sin A into 1 plus 1 is 2. By this is 1 minus cos square A minus 2 cosecant A. And this is sin A. This is 2 by 1 minus cos square A is sin square A minus 2 cosecant A. The sin A and square cancel. 1 by sin is cosecant. Therefore, this is 2 cosecant A minus 2 cosecant A equal to 0. So, sin A by 1 plus cos A minus 2 cosecant A plus sin A by 1 minus cos A. If we take sin A common in these two, we are left with 1 by 1 plus cos plus 1 by 1 minus cos A minus 2 cosecant A. So, the LCM is 1 plus cos A into 1 minus cos A. Here we will get 1 minus cos A. Here we will get 1 plus cos A. These two gets cancelled. So, this is sin A into 1 plus 1 is 2. 1 plus cos A into 1 minus cos A is 1 minus cos square A minus 2 cosecant A. But we know that sin square A plus cos square A is 1. Therefore, 1 minus cos square A is sin square A. Therefore, this is sin A into 2 by sin square A minus 2 cosecant A. This sin and square gets cancelled. This is 2. 1 by sin is cosecant minus 2 cosecant A. It is 0. Coming to the next problem, we have to prove that tan alpha by secant alpha minus 1 plus tan alpha by secant alpha plus 1 is equal to 2 cosecant alpha. So, the given problem is tan alpha by secant alpha minus 1 plus tan alpha by secant alpha plus 1, and it is equal to 2 cosecant alpha, which we are asked to prove. Now, when we take the left hand side, we have to take the LCM, and before taking the LCM in any problem, if we can get a common factor, if we take out the common factor, the simplification becomes easier. Therefore, here, if I take tan alpha as common, here we are left with 1 by secant alpha minus 1 plus here 1 by secant alpha plus 1. Now, tan alpha is here. The LCM here is secant alpha minus 1 into secant alpha plus 1. Here we will get secant alpha plus 1 plus secant alpha minus 1. So, 1 and 1 gets cancelled, and this tan alpha is here itself, and secant alpha plus secant alpha is 2 secant alpha, and secant alpha minus 1 into secant alpha plus 1 is in the form a minus b into a plus b. It is a square minus b square. Therefore, this is secant square alpha minus 1. But we know that 1 plus tan square alpha is secant square alpha. Therefore, from this we observe that secant square alpha minus 1 is nothing but tan square alpha. Therefore, here this is tan alpha and this is 2 secant alpha by this is tan square alpha. Tan alpha and square gets cancelled. So, therefore, we are left with 2 secant alpha by tan alpha. The answer is in cosecant alpha. So let us change them into sine and cos. 2 into secant alpha becomes 1 by cos alpha. And tan alpha is in the denominator. Tan alpha is sine alpha by cos alpha. If we reverse it, it is cos alpha by sine alpha. This and this gets cancelled. So finally we are left with 2 cosecant alpha, since 1 by sine alpha is cosecant alpha. Look here once again carefully. So this is the thing which we are asked to prove. We have taken tan alpha common. Here we are left with 1 by secant alpha minus 1 plus 1 by secant alpha plus 1. Now, keeping tan alpha here itself, the LCM is secant alpha minus 1 into secant alpha plus 1. Here we will get secant alpha plus 1 plus secant alpha minus 1. Minus 1 and plus 1 gets cancelled. So secant alpha plus secant alpha becomes 2 secant alpha. Therefore, this is tan alpha into 2 secant alpha. This is a minus b into a plus b. A square minus b square. That is secant square alpha minus 1. But here 1 plus tan square alpha is secant square alpha. Therefore, tan square alpha is secant square alpha minus 1. Therefore, this is tan alpha. This is 2 secant alpha. And this can be written as tan square alpha. Now this tan alpha gets cancelled with this square. So we are left with 2 secant alpha by tan alpha. Now, if we write them in terms of sine and cos, 2 into secant alpha is 1 by cos alpha. And tan alpha is sine alpha by cos alpha. If we reverse it, it is cos alpha by sine alpha. This 2 gets cancelled. Therefore, it is 2 into cosecant alpha. Cot alpha by cosecant alpha plus 1 plus cot alpha by cosecant alpha minus 1 is equal to 2 into secant alpha. Now, this is also similar to the previous problem. So in LHS, cot alpha can be taken as common factor. Then here we are left with 1 by cosecant alpha plus 1 plus 1 by cosecant alpha minus 1. Now this is cot alpha into the LCM is cosecant alpha plus 1 into cosecant alpha minus 1. Here we will get cosecant alpha minus 1 plus here we will get cosecant alpha plus 1. Now minus 1 and plus 1 gets cancelled, and this is cot alpha into cosecant alpha plus cosecant alpha is 2 cosecant alpha, and this is a plus b into a minus b. So therefore this is a square means cosecant square alpha minus 1. So therefore cot alpha into 2 cosecant alpha by cosecant square alpha minus 1. Now 1 plus cot square alpha is cosecant square alpha. Therefore cosecant square alpha minus 1 from this becomes cot square alpha. So here in our problem, this is cot alpha into this is 2 cosecant alpha by this is cot square alpha. So cot and square gets cancelled. Now if we write them in terms of sine and cos, this is equal to 2 into cosecant alpha can be written as 1 by sin alpha, and cot alpha is cos alpha by sin alpha. If I reverse it, it is sin alpha by cos alpha. These two gets cancelled. This is 2 into 1 by cos alpha is secant alpha. So the given problem is this. We have taken cot alpha common. Here 1 by cosecant alpha plus 1 plus 1 by cosecant alpha minus 1. Now cot alpha into the LCM is cosecant alpha plus 1 into cosecant alpha minus 1. Here cosecant alpha minus 1, and here we will get cosecant alpha plus 1. This 1 and 1 gets cancelled. Cosecant alpha plus cosecant alpha becomes 2 cosecant alpha. Therefore this is cot alpha into 2 cosecant alpha. This is a plus b into a minus b becomes a square means cosecant square alpha minus b square is 1. Now this is equal to cot alpha into the numerator is 2 cosecant alpha. Since 1 plus cot square alpha is cosecant square alpha, this cosecant square alpha minus 1 can be written as cot square alpha. Now cot alpha and square gets cancelled. Now if we convert them into sin and cos, 2 into cosecant alpha is 1 by sin alpha, and in the denominator we have got cos alpha by sin alpha. When we reverse it, it is sin alpha by cos alpha. So these two things gets cancelled. Therefore this is 2 into 1 by cos alpha becomes secant alpha. Next one, cos theta by secant theta plus tan theta plus cos theta by secant theta minus tan theta is equal to 2. Cos theta by secant theta plus tan theta plus cos theta by secant theta minus tan theta is equal to 2. Now in the LHS we are getting cos theta as common factor. After taking this as common factor, here we are left with 1 by secant theta plus tan theta plus 1 by secant theta minus tan theta. Now this is cos theta. This is LCM is secant theta plus tan theta into secant theta minus tan theta. Now this numerator here we will get secant theta minus tan theta, and here we will get secant theta plus tan theta. So tan theta and tan theta gets cancelled. This is cos theta. Here it is secant into secant is 2 secant theta. Here no doubt it is in the form C, a plus b into a minus b becomes secant square minus tan square theta, and 1 plus tan square theta is secant square theta, and secant square theta minus tan square theta is 1. But we also get into the habit of writing secant plus tan into secant minus tan is equal to 1 directly, instead of writing one more step secant square minus tan square, because secant square minus tan square theta is 1 and its factors are secant plus tan into secant minus tan equal to 1. So therefore, whether we get secant square theta minus tan square theta, or if we get secant theta plus tan theta into secant theta minus tan theta, either of them equal to 1. Therefore this is 1. And secant, it is the reciprocal of cos, it is 1 by cos, therefore it gets cos. And better to remember, one function into its reciprocal is always 1, Therefore, here itself we can cancel these two and put directly 2. Once again, here in the LHS, we have taken cos theta as common. Now here, 1 by secant theta plus tan theta plus 1 by secant theta minus tan theta. Now the LCM is secant theta plus tan theta into secant theta minus tan theta. Here secant theta minus tan theta, and here secant theta plus tan theta. Tan theta and this tan theta both gets cancelled because this is minus and this is plus. This is cos theta. Secant plus secant is 2 secant theta, and secant theta plus tan theta into secant theta minus tan theta is equal to 1. Therefore, this is 1. And secant is the reciprocal of cos. So, one trigonometric function into its reciprocal is 1. Therefore, the answer is 2.